Hello everyone, this is our next video of Fortinet NSE 4 series, and today video we are going to perform a lab of link monitor on the Fortinet. So before we start with the video, so let's understand the lab and then we'll move further. So this is in the middle of this is the Fortinet firewall. The port number 1 is connected to that cloud. It is used for the management. Port number 2 is connected to the ISP1 and port number 4 is connected with the ISP2, and 2.2.1 is the IP address assigned on the port number 4, and 1.1.1 is assigned the IP address on port number 2, and port number 3 is working as a LAN, and here we have the subnet is 192.168.30.0, and the one IP is assigned on this interface 192.168.30.1. So why we use the link monitor? Basically, if you have a two ISP, so we understand from that ISP perspective that we need a two default routes in order to send the traffic towards the ISP. So by default, if you add the two ISP routes, those routes will be added on the Fortinet routing table. However, the lowest IP will add as a preferred routing table and another one will not add. So we'll see this thing on the lab just now. So this was the intro of the video as well as the understanding of the lab. So let's quickly show you the configuration of the Fortinet these routers. So the configuration is pretty much simple. I have created a loopback interface of 5.5.5 so that we can try to access from that LAN subnets from this 192.168.30.10. This IP address I have assigned this LAN host. So from this LAN host, I will try to access this 5.5.5, which is the loopback address of the ISP1 as well as the ISP2. So now I have just assigned the IP addresses on these routers, and apart of that, I have not did anything. There is a simple configuration, and from this router 2, it is also a similar kind of thing. So we have not added any routing information as well because that's not needed anymore. So there is a simple thing. I just have assigned the IP addresses, the routers. So this was the interface configuration. Let me quickly show the LAN host router IP addresses also. So for that we have that. So this is the IP address 30.10 which is assigned on this LAN host. I have added one default routes towards the FortiGate firewall. So 30.1 is the IP address which is assigned on this Fortinet firewall. It is acting as the default route. So now this is the current scenario. So let's quickly log into the Fortinet and we'll see the configuration on the Fortinet perspective, and then we'll start. First we understand the concept of the link monitor, why we use it, and then we'll perform a lab of link monitor to mitigate this. So on the Fortinet side, I have assigned the IP address as port 2. This is the 1.1.1, and the port number 3, this is basically the LAN network, and port number 4 is the 2.2.1/24. So these three networks I have assigned on the Fortinet 2, 3, 4 interfaces 2, 3, 4. So this is the interface configuration. Also, I have added the default route, even 2.2. Let me open this. So I have added like a 0.0/0. The gateway will be the 2.2.2, which is the ISP F0/0 assigned on the ISP2 router. So this is the first thing. If you notice that ED value is a 10 and priority is 0. First thing, if I open this 1.2, so I have added the gateway as 1.1.2, which is this ISP address, and the ID value and priority remains same. So this is the pretty much simple the configuration we done on the Fortinet. So we can check the routing table information from the CLI, as we can check from the GUI also. So let me show you that routing table info. So we can see we have the default route. First one is but for port 2 and the second one is for port 4. So we have that everything is similar, that both routes is having the equal AD value as well as the priority. So still we can see the lowest IP address. So in Fortinet, remember that the lowest IP address will take as a preferred route in the case of same default route. So we have a default route, but the 1.1.1 is taking as a preferred route because 1 is lower than 2.2.2. That's the reason it is preferred as a default route. So this is the one thing. So let's say the current scenario. Let's understand the current scenario, why we use it, and then we'll quickly perform a lab and we'll solve that problem. So why we use it on that environment. So this is the very useful thing. It also performs the automatic failovers in the case of one link failure. So I will just access these two routers and this LAN host, means that. So let's just wait a minute to arrange this on the one screen. The third one, which is this. Now also I think I need to show the routing table behavior also. So it's better I need to add here. So in this router I will enable the debug IP ICMP. So why I am doing is so that we can see that whose router is responding of the ICMP packets. Debug IP ICMP. Because we have the similar IP address assigned on the both routers, 5.5.5 and 5.5. So that's the reason I have enabled the IP ICMP debug to see that who's going to respond. Let me ping it. Now we'll try to ping it to see that, yeah, we can see the lowest IP address is responding the ICMP echo messages. I will just initiate on now. The another router is keep on the standby state. This is the first thing. What I will do, I will turn off the debugs, and this is similar kind of behavior on the routing table. Now we'll try to, we are on the ISP one. Just for the confirmation, I will bring that IP addresses. What I will do, I will just shut down the interface. So we consider as a link down kind of thing. Now we shut down. Now this interface fast Ethernet 0.0 is going down. Now let's first check the routing table behavior. There is still same. There is no routing changes happening on the Fortinet side. What about the endpoints? So the endpoint will lose the connectivity from the ISP. If I ping, you can see the here. I'm not able to ping it. Even I have the second ISP running, but I lose the connectivity because we don't have any failover mechanism as of now. So that's the reason. If I bring it up, we will remain the connectivity back. So to solve this issue, we will introduce the link monitor. So it will perform the failover of the ISP. In the case of link failure, we can use any other things also where we want to monitor the things. So let's start the configuration tool. For the link monitor, there is a command config system link monitor. This is the first command, and then we have to create a one line, which is edit one. Here we have to set the value, set source. What will be the source interface? This will be the source interface, port number 2. So I have set it port number 2. And then they will ask for the source IP. So what we have the source IP on this 1.1.1. This will be the source IP. Now we have to define the set server to whom gonna like probing to the ICMP packets. This will be the 1.1.2. So basically for the next 1.1.2. If I show the get, so we can see the everything here in this. We have that address mode is IPv4, source interface which set to the port 2. Server config is default. We are using the ping protocol. We have added the source IP intervals. So this all information is available if we add get on the link monitors configurations. So, and if I say show, it will say the configuration. Now I will end of it. Now this configuration has been finished. To verify the status of this link monitor, diagnosis, and then we have to type the link monitor and status. So we can see the peer is the 1.1.2, which is the next hop. We have started probing with the source IP 1.1.1. Route is the 1.1.1 is sending to the 1.1.2. This is the latency information, jitter information, packet loss, and other information is there, and state is alive. And this is the verification of the link monitor. Now we'll quickly show the routing table, how routing table looks like as of now. This routes has been installed on the routing table 1.1.12. Now we'll go on the previous test what we just did. So I will enable, what I will do, I will just shut the interface. As of now, if I started the ping, it is pinging, and from the ISP2 you can check with the host name. So from the ISP2 I'm not getting any response because the traffic is only hit to the ISP1. Let me shut down. Now I just shut down it, and if I say ping, I am still able to ping on. Now this router is responding. If I say ping, now this is responded. And from the routing table earlier we have this route from 1.1.2. Now if I say this route has been removed from the routing table, we have only one route, that is 2.2.2, which is next to ISP. And if I say diagnose system link monitor status, so we'll see that link monitor is dead, and now we have shifted the traffic from ISP1 to ISP2 automatically. So once at any time, so that the shutdown. Now what I will do, I will no shut it. If I no shut it, then link monitor going to alive. Now this is alive. The routing table will again install the routing table, and from the endpoint perspective, it is moving again to the ISP1. Now we are not receiving any response yet. The reason I have not enabled the IP debug ICMP on the router because we started the link monitor. Lot of ICMP packet will show if I enable the debugs on the ISP1 router because of the probing I have started. So it is very difficult to turn off. That's the reason I have not enabled it. So now notice this interface is up, and the routing table is back to the routing table, and we can see this is alive. Now we have successfully configured the link monitor on the Fortinet firewall. It is useful for the shifting traffic between the two ISP on any other environment as well. So this was the video related to the Fortinet link monitor with the dual, in the case of dual ISP. I hope you enjoyed this video. If you enjoyed it, please hit the like button and subscribe the Firewall Experts for this kind of video. Thanks for watching.